Kia ora team, this is Mr. Dharma, and today I want to talk to you about differential equations. Now, differential equations are just equations that look like this. Can we find a function y that is a general solution to this dE, or a differential equation? And now, typically y doesn't necessarily need to be a function. We don't need a function, but this is what we start with, and then we can talk about how y moves away from being a function. So first off, all you need to do is integrate. So this side integrates to y, and this side integrates to x squared divided by 2 plus c. And that is called a general solution. Because it's got constants in it, it's really pretty. However, what we're going to do is we're going to take this notation and change it up a little bit. And so we're going to solve this by doing this. Okay, we're going to move a dx, the dx from the bottom over there. We're going to pretend it's like a fraction. And we're going to now integrate both sides. Okay, we're going to put a 1 there. So what's the integral of 1 dy? The answer is y. What's the integral of x dx? That's x squared on 2 plus c. Now some of you might ask, so why don't I have a plus c on both sides? Well, you kind of do. So imagine this. We'll have plus c1, and this one will go plus c2. But if I move the c1 back to this side, and I can just call this thing here c. And that's why we just add one constant to one side. You might ask, oh, Mr. Dharma, that's really weird. Why would you do something like that? Well, let's have a look at another differential equation, very similar, that will cause you a little strife. What if I said to you that we had 3y squared dy by dx equals x? Well, you could freak out, or you could use this method and go, I don't mind it's not a function, as long as you write your integral symbols. That what's the integral of 3y squared dy? Well, that is y cubed equals, what's the integral of x? It's x squared on 2 plus c. Remember, I don't need to add constants to both sides. And from this, you have solved differential equations. Okay, these are called general solutions. You don't need to make y the subject, because sometimes it's pretty, but most times it's ugly. So we can write it like this, and we can run with it. Sometimes they might give you some extra information. So they might say, find a particular solution. And all you need to do is you take your general solution and substitute values they've told you. So here we go. So suppose I had this, and when y equals 3, x equals 4, let's see if we can solve it. So first off, what we do is we take the dx onto the other side. We must write the integral symbols. Then we integrate, add 1 to the power, divide by the new power. And then we add 1 to the power, divide by the new power, plus c. Now we have a general solution, but for a particular solution we can just substitute. So I'm going to substitute y equals 3 and x equals 4. We're going to find c. So 3 to the 3 is 27, 4 squared 16 divided by 2 is 8, so c is equal to 19. So the particular solution for this question is y cubed equals x squared on 2 plus 19. I don't need to make y the subject or x the subject, because it's a bit tricky. So a general solution you just integrate, in a particular solution you must sub in the values they give you. Okay, now we can have harder questions. So they might give you a question that looks like dy by dx is equal to 4x times y minus 1. What you need to do here is you need to separate the variables. Okay, so the easiest way to separate is divide by y minus 1. Make sure you put your integral symbols and you integrate. So what's the integral of 1 over y minus 1? That is just ln of y minus 1, and this is 2x squared plus c. I don't need to do any more than this. And this is called separation of variables, where you separate the variables. It might look a lot funkier, it might look a lot scarier, but you can do it. So have this. What about cosine of x over sine of y? Well, I can multiply both sides by sine y. This side's still cosine of x. Then I could have the dy and the cos dx. Make sure I put integral symbols and I integrate. So what is the integral of sine dy? That's negative cosine y. What's the integral of cosine dx? Sine x plus c. Okay, so general solutions will just give you some variables on the end, and particular solutions will be telling me to substitute. So if I said when y is equal to 0, x is equal to pi on 2, I could sub that in. So in this equation, that's cosine of 0 equals sine of pi on 2 plus c. Let's work out what these are. So cosine of 0, once again, is 1, but that's negative 1, and sine of pi on 2 is 1. So we can work out that c is negative 2. So we can find a particular solution to this differential equation, that is cosine y equals sine x minus 2. You don't need to do anything more. You could multiply by negative and then take the cos inverse of both sides, but look at just how ugly this is. And because of this, we mathematicians, we typically leave it in this form. Okay, or in this form. And typically, most of the time it works, but sometimes you do need to change the form. I hope that helps identify what general solutions are and moving further into particular solutions. Right, there's one more thing I'm going to show you. These are called differential equations, but they're growth curves. So, suppose I had dy by dx is equal to some constant times y. How would I be able to solve this? Well, I can divide both sides by y, and now I have this constant on this side and this variable on this side. You can go through and integrate, and you get through with two constants. One constant that I started with and one that I'm going to introduce. So, if you were to do this, you might have weird algebra happening. Let's have a go. You get dy. Make sure I put the integral symbols. This side integrates to ln y. This side is mx plus c. And then I go e to the power of on both sides. Okay, and this is a general solution. But what we can do is we can write it a little bit prettier and go, because it's a plus in the power, it's the same as multiply outside, and we can rewrite this and we can call this, I don't know, some constant a. So we can rewrite this as y equals e to the mx Okay, and this is a general solution, and this is called growth curves. Most growth curves follow this kind of pattern, and this algebra is going to be kind of useful to you. I hope that helps. I'll catch you later. All the best, Mr. Dharma.